In 2026, the global security environment is undergoing a profound transformation. While traditional military power has long been defined by armies, naval fleets, and air forces, a new strategic domain has emerged above the Earth space. Satellites orbiting the planet now play a critical role in communication, navigation, surveillance, weather monitoring, financial systems, and military operations. Because modern economies and defense systems depend heavily on satellites, protecting space infrastructure has become a top priority for many countries. At the same time, nations are developing technologies capable of disrupting or destroying satellites belonging to potential adversaries. This growing competition has led analysts to describe space as the next major battlefield of modern warfare. Anti-satellite missiles, electronic warfare systems, orbital defense platforms, and space surveillance networks are becoming central components of national security strategies. The rise of space warfare represents a significant shift in how global power is projected. Control over space-based infrastructure can influence everything from military operations to global communications and economic stability. Understanding the technologies, strategies, and risks associated with space warfare is essential for analyzing the future of international security. Why space has become a strategic battlefield. Space has become strategically important because modern societies rely on satellite networks for critical infrastructure. Satellites provide essential services including global positioning, internet connectivity, weather forecasting, disaster monitoring, television broadcasting, and secure communications. For military forces, satellites provide even more critical capabilities. They allow real-time intelligence gathering, missile launch detection, secure communication between units, and accurate navigation for aircraft, ships, and precision weapons. Without satellites, many advanced military systems would lose their effectiveness. For example, modern guided missiles rely on satellite navigation systems to reach their targets with precision. Military drones often depend on satellite communication links to operate across long distances. Because satellites play such an important role, disabling an adversary's satellite network could significantly weaken their military capabilities without requiring large-scale ground battles. This strategic reality has motivated countries to develop technologies designed to defend their own satellites while also threatening those of their opponents. The technology behind modern satellites. Satellites are complex machines designed to operate in the harsh environment of space. They must survive extreme temperature changes, high levels of radiation, and the vacuum of space while maintaining precise orbits around Earth. Most satellites consist of several major components. Power systems. Solar panels collect energy from sunlight and convert it into electricity to power onboard systems. Communication equipment. Transmitters and receivers allow satellites to send data back to Earth. Navigation systems. These systems control the satellite's orientation and orbit. Sensors and cameras. Military and scientific satellites use advanced sensors to observe Earth and space environments. Different types of satellites serve different purposes. Communication satellites relay signals for television broadcasts, phone calls, and internet services. Navigation satellites form global positioning networks that help vehicles and devices determine their locations. Earth observation satellites monitor weather patterns, environmental changes, and natural disasters. Military reconnaissance satellites provide intelligence data used for national security planning. Because satellites perform so many vital functions, protecting them has become essential for both civilian and military systems. Anti-satellite missiles. The primary space weapon. One of the most widely discussed technologies in space warfare is the anti-satellite missile. These weapons are designed to destroy or disable satellites orbiting Earth. There are several types of anti-satellite systems currently under development or testing around the world. Direct-ascent anti-satellite missiles. Direct-ascent missiles are launched from Earth and travel into space to intercept satellites. These missiles use powerful rocket engines to reach extremely high altitudes. Once they approach the satellite's orbit, they either collide directly with the target or detonate nearby to destroy it. This approach is technically challenging because satellites move extremely fast in orbit. Engineers must calculate precise interception trajectories to ensure a successful strike. Despite the difficulty, several countries have demonstrated the capability to perform such operations. Co-orbital anti-satellite systems. Another approach involves launching satellites designed to operate near other spacecraft. These co-orbital systems can maneuver close to a target satellite and disable it through various methods. For example, they may release small projectiles, disrupt the satellite's orientation, or interfere with its communication systems. Because these systems operate in space for extended periods, they can potentially approach targets without immediate detection. This capability has raised concerns about hidden threats to satellite networks, electronic and cyber attacks on satellites. Not all anti-satellite operations involve physical destruction. Electronic warfare systems can disrupt satellite communications by transmitting powerful signals that interfere with the satellite's ability to communicate with ground stations. Cyber attacks can also target satellite control systems. If hackers gain access to a satellite's control network, they could potentially alter its orbit, disable its sensors, or shut down its communication systems. These types of attacks are often difficult to detect and may not produce visible damage, making them an attractive option for covert operations. The growing problem of space debris. One of the most serious concerns related to anti-satellite weapons is the creation of space debris. When satellites are destroyed in orbit, thousands of fragments can spread across space at extremely high speeds. Even small pieces of debris can damage other satellites or spacecraft. Because objects in orbit travel at speeds of up to 28,000 kilometers per hour, collisions with debris can be catastrophic. Scientists warn that excessive debris could eventually trigger a chain reaction of collisions known as the Kessler syndrome. In this scenario, debris from one collision could cause additional collisions, creating more debris and potentially making certain orbital regions unusable. For this reason, many experts advocate for international agreements limiting destructive anti-satellite tests, space surveillance and early warning systems. To protect satellites from potential threats, many countries are investing in space surveillance systems. These systems track objects orbiting Earth and monitor activities in space. Ground-based radar installations and telescopes are used to track satellites and debris. Some advanced systems can detect objects only a few centimeters in size. Space-based monitoring satellites also play an important role in observing activities beyond Earth's atmosphere. These surveillance networks allow governments to detect potential threats and respond quickly if satellites are targeted. Orbital defense technologies. In addition to surveillance systems, researchers are exploring technologies designed to defend satellites from attacks. One concept involves satellites equipped with maneuvering engines capable of changing orbit quickly to avoid incoming threats. Another idea involves robotic spacecraft designed to repair damaged satellites or remove dangerous debris. Some researchers are investigating the possibility of deploying space-based laser systems capable of disabling hostile spacecraft without creating debris. These defensive technologies remain largely experimental but may become more important as space competition intensifies. The economic importance of space infrastructure. Space infrastructure is not only important for national security, it is also a major component of the global economy. Satellite networks support industries worth hundreds of billions of dollars. Global navigation systems are essential for shipping, aviation, and logistics operations. Communication satellites enable international broadcasting and internet connectivity. Weather satellites provide data used for agriculture planning, disaster management, and climate research. Private companies are also investing heavily in satellite constellations designed to provide global internet access. Because these systems are economically valuable, protecting them from disruption has become a priority for both governments and businesses. The role of private space companies. In recent years, private companies have become major participants in the space industry. Commercial satellite operators are launching large constellations of small satellites designed to deliver internet services worldwide. These networks consist of thousands of spacecraft working together to provide global coverage. Private companies are also developing reusable rockets that significantly reduce the cost of launching satellites. This expansion of commercial space activity is increasing the importance of space security. Governments must now consider not only military satellites, but also privately owned infrastructure when planning space defense strategies. International cooperation and regulation. Because space is shared by all nations, international cooperation is essential to prevent conflicts and protect the orbital environment. Several international agreements govern activities in space. These agreements promote peaceful exploration and limit the deployment of certain types of weapons in orbit. However, many existing treaties were created decades ago and do not fully address modern technologies such as anti-satellite missiles and cyber warfare. As space activities increase, policymakers are discussing new frameworks for regulating military activities in space. The challenge lies in balancing national security interests with the need to preserve space as a safe environment for scientific and commercial operations. Future technologies that could shape space warfare. Scientists and engineers are exploring several emerging technologies that could influence the future of space warfare. Artificial intelligence systems may improve space surveillance by analyzing massive datasets from radar and satellite sensors. Autonomous spacecraft may perform maintenance tasks, repair damaged satellites, and remove debris from orbit. Directed energy weapons such as high-powered lasers could disable hostile spacecraft without generating debris. Advanced propulsion systems may allow satellites to maneuver more quickly and travel between different orbits efficiently. These technologies could reshape the balance of power in space over the coming decades. Conclusion: space has become one of the most strategically important domains of the modern era. Satellites support critical systems used by governments, businesses, and individuals around the world. Because these systems are so valuable, protecting them has become a major priority for national security. At the same time, the development of anti-satellite weapons and orbital defense technologies is transforming the way nations think about warfare. The future of global security will increasingly depend on technological capabilities in space. As countries continue investing in advanced space systems, maintaining stability and cooperation in orbit will be one of the most important challenges facing the international community. Understanding the technologies and strategies shaping space warfare helps explain how modern science, engineering, and geopolitics are connected in the rapidly evolving frontier beyond Earth.